We're going to do a problem today that involves computing interest through a couple different modalities, a couple different ways to compute interest. It is number 74 on page 398 in the textbook. It says, in 1626, Peter Minuit convinced the Wappinger Indians to sell in Manhattan Island for $24. If the Native Americans had put that $24 into a bank account paying 5% interest, how much money would the investment have been worth in the year 2005 if interest were compounded monthly and continuously? Which are clearly two separate problems. So the first thing I'm going to do is I'm going to compute how much the investment would be worth in 2005 if it were compounded monthly. The equation for monthly compounding interest looks a little bit like this. I've got interest equals, this is principal Okay, this you just got to commit to memory. The P here is principal. That's the principal amount. In this case, it's going to be $24. R is going to be the rate, and we said that that was 5%. It's important to convert that to decimal format. So the rate here is 0.05. Okay, N is going to be the number of times it's compounded in one T time unit. So since it's being compounded monthly and my time unit is going to be in years, I'm going to say it's compounded 12 times in a year, right? 12 months in a year, it's going to get compounded 12 times in every year. Okay. N is going to be the number of times it's compounded in a year. Again, that's the N we saw before, so that's 12. It didn't change. And then T is going to be the time period. Now we said it was in 1626 that he bought Manhattan Island for $24, and we're asking what would it be worth in 2005. Some head math gives us 379 is the number of years in between that. So once I set this all up, this is just simple plug it into your calculator and figure out. The answer we get out for monthly interest is about $3,917,360,753. Does that look right? Alright. So that's how much we would worth if we were to compound it monthly at a 5% interest rate. Now let's look at the second part of the question. Asks us what would it be worth if we continuously compounded the interest. Now the equation for continuously compounding interest is our good friend PERT, P e to the RT. Okay. P again is the same P up here. That's the principal. E is the number E. It's 2.17. That's going to stay the same. You have an E button on your calculator to make it easy enough. R again is the rate, and T is the time period in years in this case. So I'm going to say I equals, my principal again is $24. E R is 0.05, that's our rate. We said it was 5%. And T is again 379 years. And when we compute it continuously, we get 4 billion, 74 million, is that right? Yeah, 74,662,794. Okay. And just as a mental check, this makes sense because every time we compound interest, we make a little bit more money. So if we're continually compounding, we should make more money than if we were to compound at certain intervals, in this case monthly. If I were to compound it yearly, whatever, the more times I compound it, the more I'm going to make. So continuously compounded makes sense because it's more than monthly compounded. Pretty simple thus far. We're just using the formulas and plugging it in our numbers.